In filling in the table at the bottom of your page, I've already given you a number of things that can go in those places that was indicated up here. I was showing my thinking in order to be able to sketch these graphs, but a lot of this thinking can go in that table too. So the first thing is general equation. So the general equation for vertex form is y equals a times x minus h quantity squared plus k. And we learned about that in recent lessons. The general formula for standard form is one we haven't studied a whole lot yet, but we'll be getting familiar with in this unit, is a equals x squared plus bx plus c. And actually, you know more about this than you think you do because you've seen it before without the y, where we've had values for a, b, and c, and you've learned how to factor those trinomials. So we're going to be tying a lot of concepts from our factoring unit into this unit. And then lastly, for intercept or factored form, we have the general form being y equals a times x minus r times x minus s. Now what's really neat is that if you are using all three of these forms for the same parabola like we did before, we mentioned that the a value is the same for all of them. So in this case, our a value is 1 for this parabola. And so if you calculate it for one of them, you don't have to calculate for the rest of them if you're showing that parabola in the same form. Something else that's interesting to note about these general formulas is, first of all, they'll always be given to you on a summative assessment. And secondly, whenever you see those negatives, here, here, and here, is a clue that what you see is opposite to what is. So for example, if we go up here and we see x plus 1 and x plus 3, we might think that the x-intercepts are 1 and 3. But they're not. They're the opposite to what we see. So instead, they are -1 and -3, respectively. Similarly here, because the general formula has that negative in it, up here we see x plus 2. We might think, well, this means a shift to the right by 2, but because this is negative, it ends up having the opposite result, which is a shift to the left. So there's the general equation. When we look at things about the parabola that can be determined directly from the equation, we've talked about some of these. We can get the stretch or compression factor value and use its sign to determine whether it's upward or downward. So that can happen across the board for all three forms of a quadratic equation. In vertex form, some things that make it unique is that just by looking at it, we can find the vertex, right, at -2, -1, and as a result, we can also find the line of symmetry, which is x equals -2 because it goes through the x value of that vertex. So those are all things that we learned about just by looking at the equation. When it comes to standard form, the only thing besides a that we can really pull out directly is that y-intercept, okay, by letting x equal 0. Or maybe now you've discovered a cool little pattern that in standard form, this last term right here is the y-intercept. Other than that, no features relating to vertex or x-intercepts are given in standard form. So of the three forms, this one is the least useful in predicting what a parabola will look like before it is graphed. For intercept and factored form, again, besides pulling a value out of it, we obviously can get the location of the intercepts. But this is only possible if, in fact, this parabola has two intercepts, or one of the questions you saw last unit as well, it could have one intercept. If a parabola has no x-intercepts, we cannot use this form with it, and we'll explore that more in this unit. So what are some things about the parabola that can't be determined directly from here, but that we can discover with a little bit of tweaking? Well, we can't find the intercepts exactly directly from here, but we could find them out by setting y equal to 0 and rearranging for x. Okay, and we should get two possible values because of the square root idea. Okay. We also can't get the y-intercept directly from this form. In standard form, we mentioned earlier, you can't get the vertex, you can't get the intercepts, or how many of them there are, and you can't get the equation of the line of symmetry directly from here. This one, again, you can't find the equation of the line of symmetry directly, but you can by finding the average of the intercepts, right? And you Can't directly determine the coordinates of the vertex, but we talked about how you can find it from intercept form. The last thing is just the y-intercept. You can't get from here directly, but you can get it if you set x equal to 0 and sub it in. So let's do that for fun. This would become 0 plus 1, which is 1, 0 plus 3, which is 3. 1 times 3 means y would be equal to 3. And we already know that to be true for this particular parabola. Okay, let's move on and start to look at, therefore, realizing that there are pros and cons to every form. Wouldn't it be nice if we can convert back and forth between them? And that way we can get a holistic picture about a parabola from its 3 versions of an equation where possible. So this lesson we want to start looking at those conversion processes. Okay, so I'm going to begin by looking at, can we convert from intercept form to standard form? Okay, so I had intercept form over here in the last slide screen, if you will, and I had standard here, and I had vertex here. And what I want to do is I want to explore conversions back and forth between them. Okay, so intercept to standard, how can we do that? Well, let's start with an example of one. In your notes I have example 1 as being y equals 2 times x minus 3 times x plus 1. Well, guess what? You already know how to convert this into standard form. You can use FOIL. So let's do that. Let's leave the monomial alone first and do the FOIL first. So first, outside, inside, last gives us x squared plus x minus 3x minus 3. We see some like terms in here that can be collected either now or after distributing the 2. I'm going to do them now. And then finally, we can distribute the 2 to every single one of those terms. So y equals 2x squared minus 2x minus 3. And we can realize that this overlaps nicely with that general formula for standard form. So we can pull out some ideas here. We can see that A is going to be equal to 2, B is negative 2, and C is negative 3. And again, we did this in the factoring unit, so this is something you're already familiar with. So the process of converting from intercept form to standard form is done through FOIL. Again, a skill set you already have. Let's look at how we can not only go from intercept to standard, but also from vertex to standard. What does that look like? So here's an example. We do negative 3 times x minus 1 quantity squared plus 5. Okay? And y equals, sorry about that. So how can we get it into standard form? Well, again, we can expand it. So let's first of all recognize that when we see x minus 1 squared, that means the binomial x minus 1 times itself. So let's write it out in that manner so we recognize it. It is not just x squared and negative 1 squared. Let's do FOIL first. Leave the negative 3 out by itself. So we have x squared minus x plus 1. Let's collect like terms in the next line. And let's also recognize that we need to distribute the 3. Okay, so y equals negative 3x squared plus 6x minus 3. Again, I'm taking into account signs and numbers and variables for each of those terms as I distribute it, and plus 5. So again, we just have some like terms to collect, and here we go. Okay, and again, this looks just like standard form. So we can see that A is equal to negative 3, as it was in vertex form too. We can see that B is equal to 6, and C is equal to 2. All right, so again, to highlight here, going from vertex form to standard form involves FOIL and collecting like terms. I'm going to short form it up here as FOIL and collect because you actually have this at the bottom of your page. I'm just highlighting key things. Okay. All right, so some other conversions. Well, we're missing two. We need to now be able to go from standard outward. So let's look at this one first, going from standard to intercept. What are we going to have to do to make that happen? So let's start with an equation in standard form. I'm going to do y equals x squared plus 2x minus 24. And how do I get it into intercept, or what was that other word? Oh yeah, factored form. Well, I think that kind of answers the question. We're going to have to factor this. So you may recall this is a trinomial. It's not a perfect square trinomial. So my next step is, can I think of two numbers that multiply to give a times c and add to give b? So a times c means they need to multiply to give negative 24, and the b term means they have to add to give a value of 2. Can you think of those two numbers that do that? Well, 1 and 24 isn't going to work. 2 and 12 doesn't have a difference of 2. 3 and 8 has a difference of 5. It's going to be 4 and 6. Now, one of these has to be negative in order to multiply to give a negative number, but I realize when I add them, the bigger one has to be positive. So there's our two factors. So, easily enough, we can simply split this into x minus 4, doesn't matter which one you write first, times x plus 6. Now, if this had a coefficient in front of something other than 1, I would pull it out here first, okay? I'm actually going to modify this slightly, okay, so that you have examples that will fit a broader range of examples. Let's take a out first. So 1 x squared plus 2x minus 24. Now you can see that that 1 is actually going to end up being a greatest common factor from now on. And then we can do x minus 4, x plus 6. And then you clearly see that the a value is going to be 1. And our r value and our s value are going to be opposite to what we see. So r is actually equal to 4 and s is equal to negative 6. Think about why that's the case. If I put 4 in for r right here, x minus positive 4 is going to make it look like x minus 4. And if I sub in negative 6 into x, x minus negative 6 will appear as x plus 6, which is exactly what I want. So it would seem then, going from standard to intercept involves factoring, not surprisingly. So there's only one more conversion process that we need to learn about. You actually already know 3 of these. We just need to learn about this one. And so the next video is going to introduce you to that conversion process.